Dr. G Academy.
Before getting started, I would like to go through some basic theory that you might find useful in order to understand the exercise that we will do later on. It says the geometric distribution represents a number of failures before you get a success in a series of trials. This discrete probability distribution is represented by the probability density function. F of x equals p, the probability of success, times 1 minus p to the power of x minus 1. To understand why it's x minus 1, if x equals n trials, it means that you succeed on the nth try and failed for n minus 1 tries. Next, in order for the geometric distribution to be a good model, the three assumptions that have to be made are that there are two possible outcomes for each trial, success or failure. Secondly, the trials are independent. And finally, that the probability of success is the same for each trial. Okay, let's get started by reading the statement of this problem. It says, Giselle records F the number of attempts it takes her to do a ballet fouette turn in a dance class. A. State a suitable probability distribution for F. We're going to model the variable F using a geometrical distribution because we're recording the number of failures before the first success, which in this case is doing a correct fouette turn. Question B says, state two assumptions that must be made for this distribution to be appropriate. For a geometric distribution to be appropriate, we have to make two important assumptions. The first one is that the probability of success, P, is the same for every trial. In other words, the probability of doing a particular ballet fouette turn has to be constant. Secondly, each attempt should be independent from one another. The next question says, given that the probability that f is 2 equals 0.16 and that p is less than 0.15, find p, the probability that Giselle does a fouette turn correctly on each single attempt. To solve for p, we're going to use the formula, marked in red, that states that whenever we're using a geometrical distribution and we're looking at the probability that x equals a certain value that x can take, we can find out the probability by applying this formula. The only thing that changes is that we're working with a variable f instead of x. By substituting the formula marked in red by the probability that f is 2, we now have an equation in which we only have one unknown constant, p. By rearranging the equation such that we're left with a quadratic equation that is p squared minus p plus 0.16 equals 0, we can now substitute our values of a, that's 1, b, minus 1 and c 0.16 into the quadratic formula minus b plus minus square root of b squared minus 4ac divided by 2a to solve for p. We're left with 1 plus minus square root of minus 1 squared minus 4 times 1 times 0.16 divided by 2 times 1. That leaves us with two solutions, which are 0.8 and 0.2, because the discriminant is greater than 0. However, the statement clearly tells us that p is in fact smaller than 0.5, hence the solution that agrees with this constraint is 0.2. Following the previous question, D says, find the expected number of attempts Giselle takes. By using the formula marked in red that states that whenever we want to know the mean or expected value of x, in this case f, that is distributed with a geometric distribution, we can find this out by dividing 1 by p, the probability of success. Therefore, by applying this formula, 1 divided by 0.2 equals 5 attempts. Finally, E tells us to find the variance of f by using the formula marked in red that states that whenever we want to know the variance of x, in this case f, that is distributed with a geometric distribution, we can find out by dividing 1 minus p by p squared. Hence, 1 minus 0.2 divided by 0.2 squared equals 20, which is the variance of f. We've reached the end of the video. If you have any queries, please feel free to comment down below.
Dr. G Academy.